when we are discussing about line detection in the images, we use the Christ compass operator, that is having 8 different masks which are separated with 45 degrees angle. Okay, now if a line is not in one of the 8 direction, the Christ compass operator fails. So at a time we have also stated that we have to use the directional transformation called Hough transformation, that will be coming into the picture. Now let us discuss about this Hough transformation. What is the role of Hough transformation in detection of edges in the images? Of course, the edges in an image are approximated by lines, but instead of lines we do have certain other many shapes that can be traced out in a given input image, where we need to use the Hough transformation. This Hough transformation, it is one of the elegant method for direct object recognition, as the object may be a it may be like a line, or it may be a irregular shape, like it may be a kind of circle or elliptical or whatever it may be. So this Hough transformation plays a crucial role in finding out whatever the input object that is present or hidden inside the image. So it takes here the output of any edge detection operator, which may be a gradient based edge detector operator, or it may be a Gaussian based edge detection operator results. After that one, we need to apply the Hough transformation for that one. And this gradient or Gaussian based edge detector operator may produce the disconnected edge maps. So if it produces the disconnected edge map, how this Hough transformation is going to use them for its operation, we are going to discuss now. And so as I have said you, we can able to recognize any kind of shapes that are present inside the image. This Hough transformation, it transform maps all the points in a line or a curve into a single location in another parametric space. This parametric space is nothing but it is a Hough transform space by the process of coordinate transformation. I will explain about this point in the upcoming slides. Okay, let us have a discussion on this. I am having here an image, this image, and the borders between the regions are straight line. So here I do have a border, right? This one, because this is one region, this is one region, this is one region. So I do have here in this image different regions, and these different regions are separated with some borders where we are using here the straight lines. So these lines separate regions that are having with different gray levels, of course, because this region is of one gray level, this region is of one gray level, right? So in this manner all the regions with different gray levels are separated with lines here. Now edge detection is often used as a pre-processing to Hough transformation. That means we cannot directly give this as an input to the Hough transformation operator. So that means the edge detection, the resultant, this input image is passed to some edge detector operator. The resultant of it has to give to the Hough transformation. So what is the role actually this Hough transformation is playing in recognizing or detecting any objects in the image? We'll discuss. This line grouping problem. So in this line grouping problem, we are assuming some edge detection. That means like this image, you consider some edge output, edge detector output. Okay, so the resultant of this edge detector output is not so perfect, as like this point and this point may have a chance also to form a line, which may be a weak line also. That means we have n pixels that may partially describe the boundary of some object, because if I join these pixels, these pixels form definitely like it can act as a fencing for this region, or it can also act as a fencing or a boundary for this region and for this region. So we are going to find out set of pixels that make up a straight line. So in this manner you can able to feel here in this image. So this is my real world example. The input image, these are the two input images that are given to some either an edge based detector operators, which may be a Gaussian or gradient based. We are going to get the output in this manner. So after that one, these are passed, so I can feel some lines are there, because this giving me a sense that some kind of a line may also have a chance to occur in this manner, right? And also some kind of lines can be drawn in this manner, right? So these formed lines or the detected lines are the resultant of this Hough transformation, and so these are later converted into a parametric space. So what is this parameter space or the Hough space? We will see by taking a straight line into an example here. So let me have this y equal to mx plus c as a straight line with an slope as m, intercept as c. Okay, anyhow this is my y equal to mx plus c, because this is my positive slope line that is passing through c as an intercept here. Okay, so consider a point that is xi, yi. Now this is x coordinate and this is my y coordinate, and this completely, this line is present in image space, because like in an image assume that a line is present and this line is present in some image, means I am considering this as my image space. Okay, now can I rewrite this equation, that is yi equal to mxi plus c, because xi and yi, these are the coordinate that are passing through this line equation. So yi equal to mxi plus c, or c can be expressed in terms of minus xim plus yi. So this kind of representation is nothing but it is the image space, and this kind of representation giving me a sense that it is a parametric space, where c and m are the axis of your 2D system, 2D coordinate system here. And this kind of parameter space is called as Hough space, because c and m are acting as a parameter in your xy image space. Now mc is now acting as a parameter space now. Okay, right. So the same thing I have projected here. This is my image space and this is my what it is what it is a parameter space. So a line in the image, so this is my line in the image, it is corresponds to a point in the Hough space. I have a line here with red in color, so this entire line can be represented with a single point in the Hough space or the parameter space. That is a point x0 y0 in the image space. So x0 y0 or xi yi or xj yj, whatever it may be the point, these points are in the image space, are mapped to a line. So if this is a point, means these are mapped to a line in the parameter or Hough space here. Like how this line is mapped into a point space, similar manner a point is mapped into a line in the Hough space. So if this is my equation of the line, y equal to ax plus b, that means in the parameter space the equation of line may become b equal to minus xa plus y. So this green corresponds to green line, this blue point corresponds to the blue line. This blue point is having the coordinate xj and yj, and this green point is having the coordinate xi and yi. The same thing you will be having, or you will be mapping to a line in the Hough space here. Okay, so this Hough transformation, that is founding the lines or any shapes, circles, how it is possible we will discuss. So it is completely based on some kind of a voting scheme, where we, because this is my image space, this is my Hough transformation space or Hough parameter space. So instead of representing in this manner, let me represent this Hough parameter space in kind of a boxes. These boxes we call familiarly it as a bins. That means where we discretize parameter space into bins. So how many number of bins I do have here? 20. So for each feature point in the image, so these are number of points. These points have a tendency to form a line. Okay, that means for each feature point, that means each feature point in the image, you put a vote in every bin in the parameter space. Vote means logic 1. Okay, that means like I will explain you this one, that could have generated this point. Okay, finding bins that have the most values, right? So this point have a tendency to form a line in the half space. This point, this point, this point, this point, and this point. Every point is having a tendency to form a line in this half parameter space. The same thing you can see here. So in this manner, this is my parameter space. This is this point. Okay, so like this point is nothing but it is m comma c. This is my parameter space here, right? Okay, so line detection by Hough transformation. Now as I have said you, this image space is having y and x axis. This Hough parameter space is represented by considering the boxes or bins now. So as I have said you, each and every point is mapping with a line here. Each and every point is mapping with a line, and a line is mapped to a point in the parameter space. Now, so can I, because actually this is my parameter space, so this point is nothing but actually it should be this should be m, and this should be c, and this should be some x comma y. It's not m comma c. Okay, anyhow, if I consider this one as my parameter space, this one and this one, so this red point is nothing but it is a line in the image space. You can see this red point is nothing but it is a line in the image space. The same thing, this red point is nothing but a line in the image space, and all the lines are nothing but they are the points in the image space, right? Because this point is nothing but a line, this point is nothing but a line in the parameter space. The same thing you can see here. So wherever the lines, all the lines are interacted in the parameter space, we find a point. This point is nothing but it is the mapped for your line in the image space representation, right? Okay, so like we need to find out what is its capacity, or called accumulator. What is the value of this accumulating count? Okay, so if this is my line, you can draw like this. You can because if it is a 135 degrees line, if you can take this one as a reference, if this is my 135 degrees line, draw a bins. So all the bins are occupied with 1 1 1 1 1. Next, if this line, so this line is there, this line is a 45 degrees line, right? So 1 1 1 1 1 1 up to like this. So whenever there is an intersection of two lines, at this point my accumulator count will be increased. That means previously if I had drawn one line, means it is, this box is 1, but if I have drawn one more line that is passing through this bin, means definitely the bin count or the bin value increases, right, by 1 point, because these two lines are intersected at this point. If there is one more line like this, the bin count will be 3 here, and the accumulator, actually we say it is an accumulator, and if there is one more line that is present like this, the accumulator array will be having a count of 4. So in simply, quantize parameter space m comma c, this one, create accumulator array a of m comma c. So initially I don't have anything. If I hadn't drawn any lines, a of m comma c is 0. For each image h, xi, yi, h is nothing but a line. So that means a line I have drawn here. Increment a of m comma c, that is a of m comma c plus 1, increment. So for every line there will be an increment. If m comma c lies on the line, right? So if this m comma c, as I have said you, because this point is m, this point may be c. So if m comma c is lines on the line, find the local maxima in C equal to minus xim plus yi plane. So this is my accumulator, that is m comma c. Now the same thing, but there is a problem. For how long the bin count can reach? Is there any limit? We will see. So the accumulator may have a range from minus infinity to plus infinity. If this happens, that means many number of points are present, right? Many number of points are present on that line. So if many number of points are present on a particular line, means I have a tendency to draw many number of infinite lines that intersect at one point. So where my bin, or what I should say, this accumulator array count may also reach to infinity. So large accumulator. If large accumulator means more memory and more number of computation also simultaneously involves. So in order to overcome this one, instead of representing a line in a 2D Cartesian coordinate system, I would like to represent the line in a polar coordinated system, that is x cos theta plus y sin theta equal to rho. So the theta is having the limits from 0 to 2 pi and rho is having the limits from 0 to rho max. Let me discuss the same concept here. So I have said you, I need to convert a line or into a image space. The thing that is present in the image space is to be converted into a Hough space here. So for which what I am doing, so there will be a problem with m comma c space. Okay, that means Hough space. So an unbounded parameter domain, because m can be unbounded, right? Slope can be unbounded. Why I am saying it is unbounded means vertical lines require infinite m, because y equal to mx plus c is there. So for vertical line, if your line is vertical means definitely the slope is, so I am leaving it to you. Now vertical line requires infinite m. So what is the alternative solution I do have here is polar representation, that is each point will, so here in normal case a point in the image space is nothing but it is a line in the Hough space. But coming to whenever I use this kind of a polar representation of a line instead of a 2D Cartesian coordinate representation of a line, this point will map to a sinusoid in the parameter space having the axis as theta and rho or r. There in that case, in the earlier case, what happened? In this case, a point is converted into a line, or a point is mapped to a line, or a line is mapped to a point here. But coming to here, a point is mapped to a sinusoid curve. So this is mainly to overcome the drawback that was happened because of the infinite m, and also because of this larger accumulator, which involves with more memory and high computations. So to overcome that one, we are using this polar representation of a line. So if I have here 2 points on this line, this polar representation, this polar line, so one is at this point and one is this point. That means I do have two sinusoids. One sinusoid is in this manner, one sinusoid will be in this manner. So this is my, on my this vertical axis I will be having rho, on my horizontal axis I will be having my theta. So this is this point is giving me a sinusoid and this point is also giving me a sinusoid. Okay, this is the equation of this curve. Okay, and coming to, I do have here 4 points on this line, and this line is separated with rho naught from the origin, and it is theta naught, inclined theta naught with this reference axis called x-axis. So for each and every point there will be some sinusoid, some curve here like this. So this is p naught, p naught point is giving me c naught curve, p1 is giving me c1 curve, p2 is giving me c3 curve, p3 is giving me c3 curve, and p2 is giving me c2 curve. Whenever all these 4 curves intersect at one point, This point is nothing but this line. So this entire line is mapped to a point in my parameter space. This is the thing of conversion into a parameter space. So the same thing you can see, these all the points have a tendency to join as a line. So that means this entire line is mapped to a point in the parameter space as I have said you. So this is my point here. Now for every point on this line, nothing but there is a sinusoid in the parameter space. You can see like this, like this, like this. So in this manner, so in the second figure, I can feel there are some lines. So these like I can feel there are actually 2 or 3 lines, some kind of, this is one line, have a chance of probability to like form a line here, this line as well as this line, right? So in this manner, so this is 1 point, this is 1 point, and this is 1 point. So for these 3 lines there will be 3 points. This point indicates, this point in the image parameter space indicates it is a line in the image space. That's it. So this is about image space and this is my parameter space. And these votes are nothing but the number of accumulators, because if I have infinite number of points on this line means that means I may have n number of votes. So that is what it is indicating me. The same thing, these 4 points are having a tendency to form a line. So for each and every point there will be a sinusoid in the parameter space. So whenever all these 4 sinusoids intersect, so this point is nothing but this line. Okay, this line in the image space or the edge or a line, whatever it is. And if there is a single point means there is a single sinusoid, because it is a single point means it is nowhere have a chance to form a line. So it is also nowhere have a chance to link with any of the different sinusoid. Okay, so this is about the transformation from image space to Hough space. And this Hough transformation is also helpful for finding out the circles. Like we do have the equation of a circle as x minus a whole square plus y minus b whole square equal to r square. So this is my y-axis, x-axis, this is my a and b, this is my center of the circle with coordinates as a comma b, and the radius of the circle is r. So if I took any point on the circle, it is xi, yi. So xi, yi are the point on the circle. If radius is not known, that means I may have minimum radius or I may have maximum radius or I may have any of the radius in between 0 to infinity. Radius is not known. So simply I can use 2D Hough space like this. If use accumulator array, that is a comma b. Like in the time of a line, like Hough transformation, how it is useful for finding out the lines. Like in the finding out the circles also we do have here the accumulator array. Okay, so if the radius is known, I am using the accumulator array, that is a of a comma b comma r. So the same thing here, there each point on a line is giving me a line, a point is giving me a line in the Hough space. Here a point on the circle is giving me a circle in the Hough space. Here the same thing you can see, a point on the circle is giving me a circle in the Hough space. So if I consider 3 points here, 1 point, 2 point, 3 point, these 3 points are giving me 3 circles in the Hough space. These nothing but these points are acting as the centers in the Hough space. So whenever these 3 circles intersect at a common point in the Hough space, it is nothing but it is the center, it is a center point or it is the origin point of your circle in the image space, or it is the or it is the center of the circle in the it is in image space. So the same thing I have given here clearly. This is my edge pixel, this all the dots. This is my parameter space, of course. This is my parameter space, because if I consider this as my edge pixel, this will be my parameter space, and input edge image. So this is my input edge image. So all the points in the image space are nothing but they are acting as a centers for the circle in your half space. Okay, because these number of centers, these all are the points, these all the points are acting as a centers in your half space. So if input edge image, okay, and accumulator point is this one. Okay, that means whenever all these circles in your half space intersect at a common point, this common point is nothing but it is a center, or it is the center of the circle in your image space. In this manner, like in this case, I will be knowing what will be the radius of my circle. So this is about radius of space. So in this manner, one can able to find out a line, circle, or any kind of object which is having some shape. By using Hough transformation, one can able to find out easily. So this is about Hough transformation, and thank you and have a nice day.